Today we'll be exploring how to use depth first search and breadth first search to code an algorithm to move from location A to location B in a maze. For a simple introduction, depth first search is the search that goes deep and deeper before trailing back and looking at different routes, whereas breadth first search looks at different paths at the same time to find the most optimal path. Let's preface with the fact that the code of breadth first search and depth first search is almost exactly identical. There's only one line of code which changes. If you would like a more in-depth explanation, the CS50 lecture is linked down below. The video also uses similar code to explain this topic. Now turning back to the code, we begin with the node class. The node class has 3 items: the state, or specifically the index on the maze, the parent, the previous state the new node came from, and the action that was taken to come here. Now we create a new class which we call stack frontier, since the frontier in this class is stacked upon each other. In this class, we create a new empty list frontier in which we will add our nodes we have yet to explore. When we reach our goal node, or state where we have found our solution, we will retrace our steps to find the solution since our actions and parent nodes are saved in the nodes. We have a new function that checks whether or not our state is explored, a function to check if the frontier is empty, and another function to remove the node we explored. In depth first search, we remove the last node. The cake frontier class is the same as the stack frontier class, except the remove function removes the first node since it's a breadth first search. Now let's move on to the maze class. We begin by defining the index of start and end, the height and width of the maze, and we also create a wall variable that is a binary maze which is false where we can move and true where we cannot. Next, we define our neighbors function, which simply tells us what places in the maze we can move, given we are at a specific state. Finally, we write our solve function which starts at the initial node, and depending on the type of algorithm, we perform our next few actions. We first check if our node is our goal. If so, we return. Else, we explore the first node. In other words, call the neighbors function and see what are the possible next states we can explore. If we're using depth first search, we will use stack frontier and use cake frontier for breadth first search. Now we can define our maze and our location of the start and end and decide to run our program. This is the output we receive, and now following the steps, we go up, to the right, to the right, to the right, to the right, then up, then right again, then up, and finally up, and reach our B.